In this series of videos, we will create a destructible 2D terrain in Unity that I have used in my 𝗃𝗃𝗀𝗃 game. You can download the full project from my itch.io page, link will be in the description. I will try to cover all of the systems from that project here on YouTube. Hi, I'm Peter and welcome to Sunny Valley Studio. To follow along with this destructible terrain tutorial, there will be a Patreon link where you can download the starter project as a Unity package and the Unity 6.2 project compressed as zip file. Alternatively, just grab the Texture2D as PNG. To set it up, either create a new 2D project and import the package or just the texture asset, or unpack the zip file and use add project from disk and open it in Unity Hub using Unity 6.2 or later. When you have the starter project, there is a scenes folder in the projects tab, open it and open the destructible terrain scene. The map texture is in the _art folder in the made by Sunny Valley Studio, there is map_1. If you select it in the inspector, you will see that the read-write property is checked. This is because we are going to read the pixel data from this texture asset, and for that we have two options. We can read the pixel values and create a tilemap. Alternatively, we can duplicate the data from our texture asset into our own Texture2D object. In this tutorial, I will show you both ways. We are going to create the visualization by duplicating the pixel data into a Texture2D object, while also creating a tilemap to represent our collider for the terrain. Honestly, this is just because I have started with the Texture2D solution for rendering our map and then found out that the Tilemap collider is very performant when it comes to runtime modification, although you need to implement chunking. But hey, this way you will learn both methods. So let's start creating a modifiable Texture2D so that we can start making holes in it. In our project, let's go to the hierarchy and let's find the terrain generator object. I'm going to right click on it and add a child object 2D, sprites, and let's select triangle, and I'm going to call this terrain renderer. When we have that, let's assign map_1 as the sprite renderer's sprite, and we should see the map appearing in our game view and scene view. If your game view looks a bit different than mine, no worries. We are going to get the sprite from the sprite renderer. This is why we had to enable the read and write option in the import settings for this texture. Anyhow, we now need to go to the project tab and go to _scripts folder. We already have one script called destroy unfinished. I'm going to explain what it does later, but right now we want to right click here, create, and let's create a new monobehavior script. I'm going to call mine ModifiableTexture. And let's open this script up. The main idea here will be to create a new Texture2D out of our map sprite so that we can modify it and render it back in Unity. This will be a plain C# script, so let's remove ModiBehavior inheritance, and update and start methods are also unnecessary. We will start by defining variables, so let's type private Texture2D, and we are going to call it m_texture to store our texture, so the duplicate of our sprite. Next, private sprite, and we are going to call it m_sprite because we need to generate sprite from our texture, because we want to use the sprite renderer that exists in our project to render our texture, and it can only be assigned a texture that has texture type sprite, not a Texture2D. Now to define it, we need to also know private vector2 m_pivot, since this defines a sprite, as well as private float m_pixel per unit value. You might be expecting that we define it as an integer value, but if you open the sprite, you will see that the custom pivot is defined as a float value between 0 and 1, and that's what we need to pass to create a new sprite from a Texture2D. We will also need two properties, public Texture2D texture that returns an m_texture and a public sprite that returns m_sprite for later use. To assign those values, we will generate a constructor, so private, the name of the class, so ModifiableTexture, that takes in Texture2D, vector2pivot, and a float pixel per unit value, and we are going to assign all of those. Now we are left with the sprite that we will need to generate based on this data. So when you have the constructor created, we're going to type recreate sprite. This will be the name of a method. And in Rider, I can go to right click, show context, and create a method. And you can do something similar in Visual Studio. Instead of throwing an exception, I'm going to type m_sprite equals, and we can call sprite with capital S, create, and the IntelliSense gives me the input values. So we are going to pass the texture to the create method. The new rect will define the size of it. So we are going to take the width and height from our m_texture. We need to pass the pivot. So m_pivot will be the pivot that we pass. We need to also pass m_pixel per unit. And next, there are some additional properties that we need to pass, which is extrude 0. Next will be the sprite type, so sprite mesh type dot full rect. Border, so vector 4, and we are going to type 0. And lastly, we want to define if we want to generate a collision shape. We are going to pass false because we are going to generate a collision shape using a tilemap collider. You can visit the documentation to learn about what each of those parameters do. For example, we use full rect because the other option is tight, but this would make Unity recalculate the shape that we generate after we modify it, so that's why we are using full rect to speed up the rendering process. Now, we need to have a way to call this constructor, and since it is private, it can only be called from within this class. So I'm going to create a static method, public static, and this will return ModifiableTexture, so the object of type of this class, and we are going to call this create from sprite. And we are going to pass a sprite as a parameter. And now we can call this constructor calling the static method on this class. Since we will access the size of the sprite often, we are going to type rect equals sprite.rect. This will give us a reference to the width and height because we can access it from this object. Next, let's create a Texture2D texture equals new, and we're going to pass as an int value rect.width and int rect.height. Beside that, we want to specify the type of the texture, which will be texture format, and we are going to use 𝗮𝘃𝗲32, and we do not want to generate MIP maps, so we are going to pass false as the fourth argument. 𝗮𝘃𝗲32 represents 4-channel RGB texture format with 8 bits unsigned integer per channel. In the inspector, if you select map_1, it is described as 𝗮𝘃𝗲8, which I believe is 8 bits times 4 channels, so 32, which should be the same as we described in our script. We also should set the texture.filter mode to be point since we are using pixel art map. Now let's copy the data from our sprites texture. To access the pixel values, we are going to create color 32 array pixels equals our sprite.texture.getPixels32, which will get all the pixel colors. Next, we are going to call texture.setPixel32, and we are going to just pass the pixels, the pixel values that we have read, and we need to call texture.apply on our new texture. This is important because this method copies the changes that we have made to the texture from CPU to GPU, which is an expensive process. Last two parameters that we need to pass to our constructor is the pivot and the pixels per unit value. A sprite has a pivot value as a vector 2, but it is defined in pixels rather than between 0 and 1. So let's normalize those values by creating a vector 2 normalized pivot equals new vector 2, or we can just pass the parentheses, and inside those parentheses let's type sprite.pivot.x divided by the rect, so the size of the sprite.width, and we need to do the same with the y value, so we are normalizing this between 0 and 1. We can read the pixels per unit value from our sprite, so let's just return new modifiable texture, and let's pass the texture, so what we have copied, the normalized pivot and we need to pass the sprite dot pixels per unit. So this way we can create this object that stores a reference to a texture, and we can access those using the texture and the sprite properties. Okay, let's save the script. With this script ready, let's take a break, and in the next video we will test it by making some holes in our map. Also, a big thanks to my patrons for supporting the channel. You are awesome!